Right, so getting a bit more done. So speaker terminals in. Now they come with like an assortment of lock washers, so each one has a brass nut on it, a couple of brass washers and two of those black little locking washers. So what order did you put them in? Chug it if I know. Well, I've put one of the locking washers on each one between this nut and the plastic, because it stands to reason to me you don't want this coming undone when you're trying to twiddle these. So I figured the brass ones probably want to go in between the terminal that's going to go. There's going to be one of those solder lugs will go on there. Let me find one a second. Where did I put them? Hang on a minute. So yeah, one of these things, that's probably one of the small ones that won't fit, but one of them's going to go on there, so I figured it's probably going to want sandwiching with one of these either side of it. That way you get the nuts nice and tight without that trying to twist. And so I'm kind of figuring, yeah, one of these will sit this side of this nut and lock that bottom washer against there, so that one's still, and then this bit goes on like that, and then that bit, and then nut. That's what I'm going with anyway. So that's that. Few boards. There's this one here. This is for the impedance selector switch. So these terminals are at a slight angle. So you can only put this board on one way round. I did have to twist them a little bit more, but the board and the holes aren't like that, they're like that at an angle. So noticed on here you've got two little terminals there for the negative feedback lines to come out, and then there's the ground point for the negative feedback line. And if you look on the switch, let me put this up a bit higher. So if you look on the switch body, I don't know if you can see it, there's a little plus sign there. Well, from what I can gather, what that means is when you've got this switch on here, when you put it in the amplifier, that plus sign, so you got the plus for the two speaker posts, and the plus sign will line up with them when it's in there. That means when it's in this position, these two, when it's down towards plus, these ones join to this one, and that's the 8 ohm tapping to the speaker output, which then matches with 8 ohms there. So that makes sense to me. That's the way it wants to go. I will check that with the meter, but I'm fairly certain that is correct. Other things. This one is the volume pot. Will clip onto there. That's for left and right out, which go into the amplifier chassis. So it comes with some small wires. Now you can solder them on one of the boards, and then on the other board you've got two connectors. It's up to you, I guess, which way around you put them, but it makes sense to me that I'm going to put them connectors on the board, and these will be soldered straight to here. I have finally noticed on here the main board, if you look, there's an NF, it's marked NF there and there, which will be where the single wire from this terminal, so the negative feedback line on here, you need to make sure the white lines up with the plus. The black one that doesn't come out, it's not needed because the negative is going to route through this point. And so this will go respectively into that point on the board left and right channel. You need to make sure you get your phases right, because otherwise you'll be trying to send a feedback signal from this amp into that one and that amp into that one. So let's say if you did that, you had, say, the left one feeding to the right. If you had the left input connected, the left amp will be trying to play, it would have no negative feedback going off of itself. Its negative feedback will be going into the right amplifier. The right amplifier would then be inverting the signal to some extent, so you'd get sound out of both speakers, but there'd be an inversion on the right channel, but then the inverted right channel's negative feedback would be trying to feed into the left, and you'd get some weird balancing act coming through, and you'd get a very low level signal. Yeah, you can imagine. You don't do it, just don't do it. So now back to what I was saying in my last video with the negative feedback line. So I figured out why they give you so many connectors. One of them, they want you to go, cannot see the screen on this camera. So one of them they want you to go on here possibly, or a solder lug, it's hard to say. But you're going to have 4 for the speaker terminals. There will be 1 for the earth to the chassis, 1 to the earth to there, and they want you to have 1 for the negative feedback line to the amp. But as I said, that is not a good place to be bringing negative feedback line to. This ground terminal off here, I'm going to run a single wire from that, and it is going to go here on the board. I'm scraping this solder mask off and it's going here. Because if you follow the 0 volt rails, you've got the 0 volt rail for the input connector, and the next one along is the grid resistors for the input on each triad. Ideally, these should have been connected before this point electrically. So the input terminal, say this 0 volt here, should have snaked its way round to here, and then actually electrically after that connection should have come to this point. If you want to leave the in connectors here, really what they should have done is the input connectors should have been here and here, and the input signal wire traced its way around. But of course, the problem with that is you then have a longer run on the board. You could pick up AC, heat and noise. This shouldn't really be an issue because there should not be any current on this. If there's no current on a wire, it can't develop a voltage. But just for the sake of thoroughness, and just for procedurally following the correct way you lay out a signal follows earth 0 volt bus bar, the last terminal connection on that 0 volt rail should be the 0 volt reference to the input connectors and earth. But hey ho, never mind. So yeah, that's where the 0 volt feedback rail is going to connect. I'm missing some connectors, so they give you a connector for the AC in on the board, and they give you connectors I can solder. These ones are going to go on here for the input terminals. They're polarised, you have to make sure you get them the right way round. But they don't give you any connectors to go into these wires, so I'm just going to directly solder wires into them. Like I said, there's no connections on the board for the heater wiring. But what I will do, the other terminals, a couple more of those crimp terminals, it dawned on me, are going to be for the not the output transformers, the power transformer. Well, yeah, the heater wiring on the power transformer, the 0 volt tap on the dual 3.15 volt winding, which is going to connect to the input triodes, and one side of the 6.3 volt winding for the output tetrodes is going to need to be referenced to this point as well, and a chassis earth for the mains, well, mains earth to the circuit board, and I'm going to have a chassis earth to the mains on here as well. Transformer wise, when the transformers are on, you get a small bit of room either side of them, like half the semicircle. So I'm going to have the low impedance sides, the speaker terminals basically, side of the transformers going into the middle, because on the board the primary connections are there, so I'm going to run these up this side of the transformer, so that'll come up here and here on the edge of the chassis. Then the low voltage speaker terminal ones will come out there and shortest run to this switch here, and then goes across to the speaker terminals. So yeah, it's just more wiring now basically. So it comes with some screws, you've got some self tappers, these are plastic, there's like a plastic body, so the self tappers for that one. There's some countersunk ones go into here, These are going to be, yeah, they're just flat, so you don't really need countersunk ones on them. That's not countersunk, so I'm going to just say use flat ones on there. But again, there's very little instruction. I couldn't find anything online. Tried googling it, I found nothing. So I'm documenting this, so hopefully if someone else wishes to build one and they're kind of just sat scratching their head looking at it thinking, well, what the fuck do I do here? I've got no instruction at all. Hopefully these videos will be of some use to them, but who can say? So anyway, I'm going to carry on building this up and try and get everything mounted. The problem's going to be I really need to mount the transformers for the wiring runs, but I really need to get the board wiring run done before I get the transformers in. So I think I'm going to have to tack all the transformer wires onto the board. I'm going to get my drill and twist some solid core copper wire for the heater wiring, and yeah, mount the board and just bring the wires up, have them flying, then bolt the transformers on and connect all the wires up. I'm just going to have to give myself on all the wires some extra so I know I've got enough to bend it into place. But yeah, wiring wires, you really always want to do heater wiring first because you don't want to be trying to work your way around other wires. Generally, when you're building a valve amplifier, if you like doing a circuit board like this, really what I should have done, or what I would normally do, is put the heater wiring in first. But if you do that on here, then you're going to struggle to try and get all the other components and stuff in. So I'm going to have to get creative doing the heater wiring. But the wire they give you is no good for heater wiring. You don't use multi-core cable. It's not twisted. There are some bunches of wire I'm going to use. For instance, these look pretty likely and let's say 4 ohm and 8 ohm tapping for speaker wiring. There's some other groups of wire which looks like they will work for the high tension, not high tension, well, the B plus and anode outputs to the output transformers, and some of the other wiring, like I said, it's not getting used. And give you a nice piece of 4-core wire for something. I have no idea what. Who knows? But meh. So anyway, yeah, go crack on and report back when I've got a bit more done.